Okay, good afternoon everyone and to the viewers online. Today, Yushan and my name is Aditya Kashikar, we'll be covering 3 chapters from your Finance 3000 course, Principles of Finance. The 3 chapters that we are going to be going over are Time Value of Money, which is chapter 5 of your textbook, Valuing Bonds, which is chapter 6, and Valuing Stocks, which is chapter 7. The point of this review session is to try and give you some practice in solving numerical questions which come from these chapters. Most of you might know some of the concepts that are there in these chapters. For example, you might know about an annuity, you might know about what a bond is, you might know what a coupon rate is, but many of you might not have had enough practice solving questions. So today the goal is to try and get you on those calculators and solve as many questions as possible. Any questions at the beginning? Anything that you'd like to ask me? Okay, so let's get on with it then. So I'll be covering chapter 5 and Mr. Yushan will be covering chapter 6 and 7, which are bonds and stocks. So let's get to chapter 5, which is time value of money, also called TVM. So here's the first question. I hope all of you are able to read the question clearly. If you're not, let me know. We'll see what we can do about it. Anyway, so you're considering the purchase of a home that would require a mortgage of $250,000. How much more in total will you pay if you select a 30-year mortgage at 5.65% rather than a 15-year mortgage at 4.9%? Okay? Round the monthly payment amount to 2 decimals. That's the sort of hint that's given to you. So the first thing that you have to notice about this question is that the payments that are involved in this question are of a monthly nature. Okay, that's a very, very important statement. Okay, that means you're going to be paying every month, month on month. Okay, so that's point number 1. So what's happening in this question? There are 2 alternatives. You have a 30-year mortgage. Okay, and how many payments is that? That's going to be 30 multiplied by 12. That's 360 payments. Okay, that's one option. Then you have another option, which is a 15-year plan, and that's going to be 15 multiplied by 12. That's 180 payments or 180 periods, 180 months, and this is 360 months. Okay, so that's one part of the question. What's next? You've got 2 interest rates. So here they say that the interest rate is 5.65%. Okay, so the important thing to remember here is that whenever they quote the interest rates in any question like this, the interest rate that they're actually talking about is what is called an APR. Okay, it's the annual sort of a rate. It's not the monthly rate. Okay, and that's very, very important in this question because the payments are monthly, but the rate that's given to you is actually an annual rate. Okay, so you need to convert this into a monthly rate. That should be the first thing that you do. So what's the monthly rate going to be? It's going to be 5.65 divided by 12. Okay, because there are 12 months in a year. Okay, so that's an important thing. Similarly, here the monthly rate is going to be 4.9 divided by 12. Okay, so that's another important issue. And then once you have these 2, you can go ahead and calculate the PMTs. The PMT stands for the monthly payment in this case, and similarly for this case as well, we can go ahead and calculate a PMT. Okay, so this is the basic setup of the question. I've sort of already solved this question, so I'm just going to show you my solution. Let me just put these things down here. Okay, so yes, so scenario A, 30 years, which means 360 payments, which means n is equal to 360 as we just discussed. The interest rate is 5.65, but we need the monthly rate, which is 5.65 by 12, okay, or this number here. Okay, and now if you want to calculate the PMT on your calculators, it's a very, very simple step. You just have to feed in these points. So let's actually go ahead and try and feed these points to the calculator, these data points. So I hope everybody's got their calculator with them. If you haven't, just try to follow the steps try to make a note of the steps that I'm doing here so that you know what to compute when you go back home. Okay, so one of the first things that I do on my calculator is I try to set it to 4 decimal places. I don't know if you've all done that. If you've done that, that's good. But if you haven't done that, let me show you how to do that. So the first thing you do is you click on the second button here. Okay, this button that's called second, and then you click on the decimal point button. Okay, the function that's actually going to work is the format that's written on top of the decimal point. Okay, so when you click on the decimal point button, it's going to ask you DEC equal to something. Okay, and at this point you press 4 and you press enter. Okay, and if you do that, this sets your calculators to 4 decimals, and it's usually a good strategy to keep your calculators at 4 decimals, because sometimes, because you're working with percentages and so on, you might tend to miss out on important numbers. Okay, so you have to try and keep it to 4 decimals as much as possible. Okay, now that that's done, let's try to feed in these data points. So our goal right now is to try and compute the monthly payment for the first plan, for the 30-year plan. So the 30-year plan, we will try and key in the buttons on our time value of money buttons on our calculator. Okay, now the time value of money buttons on a calculator are these 5 buttons here: N, I by Y, PV, PMT, and FV. Okay, these are the 5 buttons that we are going to use for all the 3 chapters that we're going to talk about today. Okay, so the first thing you need to do is you need to try and clear the memory from your calculator. Anything that's stored in these buttons from your previous calculations is still stored on there, so you have got to clear it out. The way to clear out the memory is to click on the second button here, and then to click on the FV button. Okay, the function that's actually going to work is the thing that's written on the top here, that's CLR-TVM. CLR-TVM stands for clear time value of money. What that means is essentially if you had used these buttons in the past, and if some results were stored in these buttons in the past, then all that's gone, and now you can start fresh again. Okay, it's very important that you do this, because if there's some number that's left behind on the calculator from some previous calculation, then that's going to mess up your new calculation. So you have to clear every single time you do a calculation. Okay, now let's start feeding in the numbers here. So the first thing we try to feed in is the N. Okay, now most instructors might actually tell you that N stands for number of years. I would hope that you think of N as number of periods rather than number of years. Okay, think of N as number of periods, and in this case the number of periods is 360. There are 360 months that we are talking about. 30 years is 360 months, and the payments are happening on a monthly basis. That's point number 1. Point number 2, we need to put in the monthly rate instead of for the button that says I by Y. I by Y stands for interest per year, but again think of it as interest per period. Okay, not per year. So the interest per period in this case is going to be 5.65 divided by 12. So let's compute that first. Divided by 12. Okay, that's this number here. I'm going to put this into my calculator as I by Y. Okay, that's fed in the I by Y to the calculator now. Now, what else do I have? Do I have the PV of this deal? What's the present value of this deal? So the present value of this deal is the value of this home. That's $250,000. Okay, this plan is equivalent to paying cash of $250,000 right now. Okay, if they were not equivalent, then the business would not work basically. Okay, so this plan of paying over 30 years is financially equivalent to paying $250,000 right now, and therefore the present value of this plan is $250,000. Okay, now you put in $250,000, and here I'm going to do something. I'm going to put a minus sign here. Okay, I'm going to put in a minus sign here because I want my answer to be a positive number. Okay, and this is the key thing to think about when you're talking about the financial calculator. The signs, they are very, very important. Okay, so you have to sort of assume that you're dealing with a cash flow where there are inflows and outflows. Okay, and everything balances out at the end. So therefore, if you're going to pay an amount through the course of this through the plan, you must balance it out with receiving an amount of $250,000 right now on your calculator. It should be as if you're receiving $250,000, even though you're not. Okay, But the point is that's how the calculator works. The calculator needs this balancing out to happen. Okay, so I'm going to put in a minus 250,000 here, okay, as PV. What's the FV for this plan? So why is it 0? So at the end of your plan, once you pay the last installment, you don't owe anybody anything, right? That's why it's 0. Okay, at that moment there is no further owing to anyone, and therefore that's 0. That's the future value of this plan. And then we simply click on compute and PMT. Okay, so that gives me a number of 1443.09. This number here. Okay, so that's the payment that would happen if I went for the first plan. If I went for the 30-year plan, it would mean that every month for the next 360 months, I would be paying $1,400, $1,443.09. Okay, every month, month on month. That's one thing. Now, I could do the other scenario, which is scenario B. Scenario B is where I pay for 15 years. 15 years means 180 payments. So once again, I need to try and compute the PMT for the second scenario as well. So as usual, the first thing you do is you clear the memory. You clear the memory. Okay, that's the most important thing. If you don't do that, you're going to get wrong answers. So you clear the memory, and then you start feeding in the numbers that we know. So for the second scenario, the number of periods is 180. Okay, the interest rate per period is going to be 4.9 divided by 12. Okay, and then that's I by Y. Then you have the same PV, so 250,000 with a negative sign as the PV. You have 0 as the FV. Let me just put this in once again, and then compute the PMT. If you do that, you get 1963.99, which is this number here. Okay, so there's two plans. I could choose either of these plans, and the question here is asking me what is the difference in the amount that I pay out when I do these things. So if I choose the first plan, I'm going to pay this number, this amount for 360 months. And if I choose the second plan, I'm going to pay this amount for 180 months. So the difference between these two numbers is simply this multiplied by 360. That's, you can see that here. Okay, and this amount multiplied by 180. Okay, and then you can just go ahead and put these on your calculators. The first number should amount to this much. The second number should amount to this much, and the difference is this number here. Okay, and that's option D on our choices. So any questions about this question? I just want to make a small comment. These numbers here at the bottom actually don't make too much of a economic significance. These numbers at the bottom don't mean much actually. No one actually goes ahead and computes this multiplied with 360 and this multiplied with 180. Those numbers make no sense. The 519,000 here doesn't really make sense. It's not a sensible number. It has no economic meaning. The number that has economic meaning is this number here. Okay, but this multiplication itself has no meaning. Okay, anyway, yeah.
Why do you multiply 5, 3, 60, and not 80?
Because the first payment happens 360 times, and the second payment happens 180 times, right? That's what the question is asking us. Okay, so yeah, how much more in total will you pay? Okay, so yeah, so you'll be paying this over a period of 360 months and this over a period of 180 months. Okay, is that clear? Mm-hmm. Okay, let's move on then. So yeah, that was the first question, and I took a little bit of time because I wanted to sort of go over the calculator functions and so on, but we'll go a little bit faster from here on. Question number 2. Again, this is a very interesting question. So you're ready to make the last of 4 equal annual payments on a $1,000 loan. And the loan that, when you took the loan had an interest rate of 7.77%. Okay. Now, how much of that payment, how much of that last payment that you're going to do is going towards the interest, and how much of it is going towards principal? Okay. It's a very interesting question, right? So you took a loan of 1,000, and then at the end of the first year it accrued some interest, and then you made a payment. Your principal went down a little bit, and then you made another payment at the end of the second year. It went down a little bit more, and so on. Now the question is, when you're making the last payment, what part of the last payment is actually just the interest component? Okay. So how would one approach this question? What would you try to do in this question? So one of the first strategies is to try and figure out, what is this equal payment amount? Okay, how much am I actually paying in this last installment? What is the net amount that I'm going to be paying? So to calculate that, we have a few data points in our question. So what do we have here? We have a loan, which is $1,000. Okay, and our goal is to try and compute the PMT. Okay, so the PMT for this loan is going to be such that you have n equal to 4. You have 4 periods, 4 annual payments are going on. You pay over 4 years, so n is equal to 4. Okay, then you have I by y, which is 7.77. Okay, and then you have a loan amount, which is the PV, and again I'm going to use the minus sign here because I want my answer to be a positive number. So this is a loan amount of $1,000. You have an FV of 0, and with these 4 data points you go ahead and compute the PMT. Okay, so we can do that on the calculator. You can try it out. The PMT should be $338 if you do all this correctly. Did you guys get the PMT? Yes. Okay, so is that the answer? I can see an option D which says 300.38. Is that my answer? No. No, that's not the answer, because this amount here has 2 components associated with it. There's a principal amount and there's an interest amount. Okay, and both of these together add up to $300. Okay, so the question is trying to ask me, what is the interest component of this 300.38? Okay, and that's what we need to answer. So let's write this 300.38 in a separate place here. So PMT of 300. Okay. So now think about what's happening in this question. In the last payment, okay, let's assume that you still owe the bank an amount of P dollars. Okay, it's an unknown amount. I don't know how much I owe the bank. Let's assume that for the last year, okay, at the end of the 3rd year and the beginning of the 4th year, the amount that I owe to the bank. Okay, so let me just call this end of 3rd year, or the beginning of 4th year. From a finance point of view, both of these mean the same to us. Okay, the end of the 3rd year is the beginning of the 4th year. Okay, so the point is we need to try and find out. Let's assume that the amount that this individual owes to the bank at this point in time is P. Okay, now there's one more year for this loan to go on, right? There's one more year. The loan ends at year number 4. It ends at end of year 4. Correct? So in this one more year, this amount is going to get compounded, right? There's going to be interest added to this amount. How much of interest is going to be added? So you're going to add 7.77% of interest to this. Correct? So if you owed the bank P dollars at the beginning of the 3rd year, at the end of the 3rd year, you're going to owe the bank P plus 7.77% of P. Is that clear? So at the end of the 4th year, you're going to owe the bank this amount here. Okay? And this amount must be exactly satisfied by this amount here. That's when the loan gets paid off, right? If you pay exactly this amount to the bank at the end of the 4th year, then you don't owe the bank anymore, right? So here you have an equation. You have an equation which says that P plus 7.77% of P is equal to 300.38. Okay? And you can go ahead and try and solve this. Let me just put my solutions on here. So okay, so if you just go ahead and solve this, you'll find that P is equal to 278.72. Okay, I just went ahead, I set up this equation here. P plus 7.77% of P is equal to 300.38 makes this equation here, 1.0777P is equal to 300.38, which means P is equal to, divide both sides by the same number, 1.0777, okay, and that's going to give you a P of 278.72. This is simple algebra, but yeah.
Yeah, actually there's another way to do it. If we set up again the periods become 3, and then we calculate, we're going to get this principal.
I'm sure, yeah.
And then like we subtract, let the payment and subtract.
I understand, yeah. So I'm going to do another question where I follow exactly that method. So I'm just trying to show all the methods possible, okay. So there's going to come a question where we're going to do exactly what you just said, but that's later. So is this clear so far, what I just did here? So, yeah.
Can we do it in the calculator by the amortization, like after we find the payment, just with the second plus present value, which is amortization. We set the P1 to 4, P2 to 4, then it gives us like the balance, it gives us the principal 278, and it gives us the interest 21.65.
I'm not entirely sure what you did on the calculator, but if you're getting the answer, then we can talk about it after the class. I'm not entirely sure what you did on your calculator. Yeah, we can talk about it later. Because I'm not clear what you just said, because there are once again there are several ways to solve this question. Okay, there is no single correct way. Okay, these are all these can be solved in various ways. So you might be right. I'm not entirely sure what you just said, but you might be right, of course. Okay, so let's just go ahead with what I'm trying to do here. So in this question, when we can calculate the P here. Okay, so all I did was I set up this equation where P plus 7.77% of P was equal to 300.38. Okay, now those of you who remember simple algebra, you can sort of put these things together. This is 1.0777. So this plus this is this number here, and that's 300.38. And so then you can compute the P as 278.72. So this 278.72 is the amount that's owed by you to the bank at the end of the third year. Okay. Now at the end of the fourth year, you make a payment of $300.38. So if you just subtract the amount that is owed to the bank from the amount that you actually pay, that's the interest that you paid out. That's the interest component that you paid out. Okay. So you paid 300.38, you owed the bank 278. The difference between these two is the interest that was accrued over 1 year. Okay. So that's one way to do it. There are several ways. We'll try to see if we can solve other questions with different ways. Is this clear? Okay. So let's move on then. So the answer to this question is 21.66, which is option A. Okay, let's move on. So question number 3, the salesperson offers buy this new car for $30,000 cash, or with an appropriate down payment, pay $800 per month for 36 months at 5% interest. Okay. So there's two different schemes here, two different plans. One is you either pay $30,000 cash right now, that's one scenario. Or the other scenario is you make a down payment and follow it up with an annuity. Okay. Now, because these two schemes must be equal, if they weren't equal, then you could take advantage, right? Somebody could, you could think of potential arbitrage opportunities if they weren't equal. So these two schemes must be equal, which means that the cash plus the down payment that you make, cash must be equal to the down payment that you make plus the present value of the annuity that you're going to pay. Okay. So that's the main equation that's driving this question here. Okay, the cash amount that you pay right now must be equal to the down payment that you make right now, plus the present value of the annuity that you're going to pay over the next 36 months. Okay, so let's try to get all these components. So let's try to one by one set up these numbers here. So we know this number here. This is 30,000. Okay, we don't know this number here. Okay, but we can calculate this number here. So how do you calculate the present value of this annuity? To calculate the present value of this annuity, you have a few data points in the question. What do you have here? You have a payment of $800. Okay. You have N, which is 36. Okay. Then you have the interest rate. But again, here the question is a little bit tricky. The interest rate is 5%. But every single time you see an interest rate in any question in this course, that's an APR, unless otherwise specifically mentioned. Okay? So this number 5% is some kind of an annual rate. What we need is a monthly rate, not an annual rate. Okay? Because the payments are a monthly basis. Okay? So the I by Y that you're going to put into your calculator is going to be 5 divided by 12. Okay? Because that's the monthly rate. Okay? So you have these three numbers. You have an FV of 0, and you compute the PV. Now, if you want to get a positive answer for the PV, you just put a negative sign here. Okay, because that's how the calculator works. It needs the positive negative to happen. So if you put all these things down, you'll be able to calculate the PV of this annuity, okay, as this number here, 26,692.56. Let me just write that down here. 26,692.56. That's going to be the present value of the annuity. So let's go back to our equation. So you have 30,000 is equal to something plus 26,692, right? So that something here is simply 30,000 minus 26,692. Okay, and that's going to be a number that's 3,307.44. Okay. And so this is the appropriate down payment to make these two schemes equivalent, okay, to make these two schemes financially the same at these interest rates. Okay. So the appropriate down payment is 3,307.44. That's option B, and so that's the right answer for this question. Yes.
Down payment, which also means that we pay immediately when we get in a contract of 36 months, right?
Yes, so down payment is the sort of payment that is done immediately at the moment of purchase, at the point of purchase, okay? But instead of paying the $30,000 in cash, you're paying a much smaller amount. As you can see, you're just paying 10% of the value of the car, roughly, okay? And you're getting into this other plan, annuity plan, where you pay other amounts over a period of 3 years, okay? So down payment is something that happens right then and there, at the moment, at what we call time zero in finance, but anyway. Any other questions? Was this clear? Yes. Okay, let's move on then. Question number 4. An investment offers to pay $100 a year forever starting at the end of year 6. If the interest rate is 8%, then what is the investment's value today? Okay, so it's a pretty straightforward question actually. The only sort of complication in this question is that this perpetuity, it's a perpetuity, you can see that, right? It's a payment that's going to go on forever. And payments that go on forever are called perpetuities if you look back at chapter 5. So this is a payment that goes on forever, but this is a payment that starts from year 6 onwards, okay? So in other words, if one were to draw a timeline, if this were to represent today, this is at the end of first year, the end of second year, the end of third year, the end of fourth year, end of fifth year, and the end of sixth year and onwards. And what they're telling you here is that the first payment for this perpetuity happens on this day here, okay? And so on, every year after that, okay? And you want to try and find the value of all of these payments. There are an infinite number of payments, okay? You want to try and find the value of all of these payments back at this point in time. That's what you want to do, okay? Now, some of you might remember that there's a formula for the perpetuity, for the present value of a perpetuity. Do you remember what that is?
Equal to payment.
So that's right. So the present value of a perpetuity is PMT divided by I, okay? But you must be very careful when you're applying this formula. So this formula, when you apply it to a perpetuity, you're talking about a perpetuity which starts at time 1. And this formula gives you the present value of all of these payments at time 0. Okay. So if you try to apply this formula to this question right now, it's going to give you a present value, but it's going to be the present value at time 5. Okay, and that's the key thing to remember when you solve this question. Okay, when you try to solve this question, when you simply apply this formula here, yes, it does give you a present value, but it's a present value at time 5, not at time 0, not right now, not today. Okay, so we have an extra step that's involved. Okay, and the extra step is you first bring it to time 5, and then you bring it from time 5 to time 0. Okay, and that's how you would go ahead trying to solve this question. Okay, so let's have a look at the solution. Here, so by applying the formula, we can first compute the present value of the perpetuity at time 5, and the present value is simply given by PMT by I. Okay, now another very important thing that you must remember is that when you put the I here in this formula, if it's 8%, you put 0.08, not 8. Okay, that's very, very important, because in your time value of money functions, you just put 8. Whenever they ask you for interest rate, if it was 8 here, you just put 8, and that would be enough. But when you're calculating it on your calculator for perpetuity, you have to put 8%, and 8% is 0.08, not just 8. So you're getting a payment of $100. Divided by 0.08 is 1,250. But this is the present value at time 5, so you need to bring it back to time 0. And that's a very simple, straightforward formula. Present value at time 0 is simply the discounted value of this cash flow 5 years back. Okay, so you discount 1250 by 5 years. So 1250 divided by 1 plus 8% raised to 5. Okay, there are various ways to do this again on your calculator. There's, you can sort of put this as the FV. You can put n equal to 5. You can put I by y equal to 8 and compute the PV. It all works. They're all the same thing. Okay. Yeah, as I mentioned here. So you can just do this, and if you do this, you should get the PV as 850.73. And this is the present value of these set of infinite cash flows at this point in time. Okay. In other words, if someone gives you an option of getting these infinite payments starting from year 6 or getting $850 right now, these two are the same things. Okay, they're financially the same thing. If you had the $850, you could create these stream of payments on your own, provided the interest rate stays the same forever, but that's a different matter. Okay, any questions? Yeah.
The interest rate, would you put it in as 8 or 0.0?
In what? So when you're doing the time value of money functions, you put 8. Okay, but when you're just doing a calculation, you have to use 8%. Okay, the time value of money buttons already know that you're feeding in some kind of a percentage, so you don't have to specify the percentage again to them. Okay, but when you're just doing a normal computation on your calculator, the calculator doesn't know that you're feeding in a percentage, so you have to tell it explicitly that yes, I am feeding in a percentage. Okay.
And why is it 5, not 6?
What's this one?
For the exponent.
Because
Raise it to the 5th.
yes, because I'm at time 5 right now, right? So when I calculated the present value of all of these payments in the future, these are the payments at this point in time. Okay, so what they're trying to tell you here is that receiving $100 every year from year 6 onwards forever is the same as receiving $1250 at year 5. They're the same thing. Okay, so you could sort of replace this. You could this is the same as receiving this. They're the same thing. They're financially the same thing. Okay, so all I did was I just assumed that this is the same as this first. Not assume, I mean, I realized that this is the same as this. And then I'm still not done because I need to bring this payment back to 0. And this payment is happening at year 5. So that's why the exponent is 5 here, because I have to come back 5 years in time. Yeah?
How would we use it with the calculator? What would we put as payment for, right there at the bottom it says, you can calculate this, future value equals 1250, n equals 5, I equals 8, present value, so payment would be 0.
There's no payments. There's no payments, right? Are there any payments in between? We just, So payments are, okay. I can see what you mean here. So there were a set of payments earlier, okay. There were a set of infinite payments, but we converted that to one number, which was 1250 at the end of year 5, okay. So those infinite payments were the same as getting one payment at year 5. So there were no other payments at all. There was just one payment at year 5, and therefore I just found the present value of that one payment. Yeah, there was only one payment. There was nothing else, basically. Okay. Yeah, but the thing is, you can't call it PMT of. So are you asking me what are you asking me? Are you asking me that I should have done this? Is that what you're asking me?
Well, the future value equals 1250.
Yeah.
And so yeah, I'm saying, what would you put as payment? Meaning
There's no
the
payment.
number would you put 0 then?
Yeah.
You enter 0. That's
Yeah.
what I'm saying. Okay.
Or you just don't put it in. Yeah. If the payments are 0, you can just ignore it. There's no need to put it anymore. Yeah. Yeah.
So I have a question because you said that if we let the payment divide by the interest, then we got a present value, which also means the year 5, right?
Yeah.
For example, in another scenario, like if we receive the payment immediately right now, so will the formula is gonna be the same?
If you get the payment right now.
Yeah, I mean like if the value of today is gonna be on year 6 as well, so how can we calculate it?
I'm not sure I follow you.
I mean in here because like you let the payment and divide by the interest, then
Yeah.
you're gonna calculate in the year 5, right?
Yeah.
But however, how can we calculate in the year 6?
You can always. What do you mean by calculate for year 6? I'm not entirely sure I follow your question. Let me just. So, if you try to do that, there's 0, 1, 2, 3, 5, 6. Okay, so then you have 7, 8, and so on.
Yeah.
Okay.
So in here, I have a question. In here, you said that the first payment we're gonna receive is gonna be on year 1, right? At the end of year
6.
I mean, I want to ask another question. It's similar to this one.
Okay.
So-
Can it wait till the end of this class, or
Okay.
is it related to this question? I mean, is it? If it's related to this, then maybe we can go on. But if it's not, we can wait till the end of the class.
Okay. Yeah.
Okay. Okay. Let's move on. Is this clear? Any other questions for this question? So always remember, always keep, be attentive about what are the years that are involved in the question. And this question, it was very clear that the payments are happening at year 6, from year 6 onwards. So if you use the formula, and if you don't know what the formula means, you're just going to get the PV at year 5. And that's not what this question is looking for. This question is looking for PV right now. Okay. Moving on. So this is a very simple, straightforward question. What will be the approximate population of the United States if its current population of 300 million grows at a compound rate of 2% annually for 25 years? Okay, extremely straightforward. So you have a present value of 300 million. I'm just going to call it 300. I'm not going to put in the million. Okay. And then you have interest rate I by Y of 2%. You have N of 25 years. And you just compute the FV. Okay, pretty straightforward. There's almost nothing involved in this question. There's no complications. There's no tricks involved. There's no one trying to deceive you in this question. So pretty straightforward. Okay, so let's just put in these numbers. If you do that, you should get 492 million. Okay, so I just put in 300. I just ignored the million. You can do that as well, and then remember to put back the million after you find the answer. Okay, so this is 492 million. That's option B, and yeah. Moving on. Question number 6. If the interest rate is 6%, which of the following investments would you prefer? So, there's a typo there. It should be which of the following investments would you prefer? But anyway, so how would you go about doing this question? What would be your strategy?
First, eliminate the ones that are obviously not right that you don't need to do calculations for. So,
What do you mean by obviously not right? I don't know what you mean by obviously not right.
well, if there was, I didn't actually have the time to read through it. But for example, if there was one that said, you know, $100 100 years from now, and there was one that said $100 in 50 years, which one would you prefer?
That's still not obviously not right. If the,
The one that would be closer, you choose the one.
No,
You get the
if the
100.
interest rate is 0, then both of them are the same thing. You're not obviously, there's no obvious correct answer unless you put in everything. If the interest rate is 0,
Well-
getting $100 today or getting $100 100 years from now is the same thing.
Wait,
Same
no.
thing.
You're saying that if you get $100 today, it's the same thing as getting $100.
If the interest rate is 0, yes.
If the interest rate is 0.
Yes.
Yeah. Fair
So-
enough. Yeah.
So it's not obvious unless you specify the interest rate.
Right, but I'm saying, but the interest rate is 6%
Yeah,
right
so-
here. So.
So that's one thing. But the way, what would be your strategy? What would be the way you go about?
You should find the present value of all and see.
Correct. So you're right. But on a more general note, what you try to do is you try to bring all the 4 investments at one point in time. It could be any point in time. Okay. If you bring it all back to today, then that's calculating present value. Okay. You could potentially do the calculations for 5 years from now. Okay. Calculate all of these investments 5 years from now. Okay, and compare them 5 years from now. That will still work. Okay. So the key thing to note in this question is that you can only compare things when they are at the same point in time. If they are not at the same point in time, you cannot compare them. Okay. $500 today and $600 tomorrow are not comparable if you do not know the interest rate. Okay. So that's the main thing to note here. So let's go ahead and try to find the value of all of these today. Let's try to compare all of them today. Okay. So the payment of, so let's compute the, yeah, so I've actually gone ahead and done that. So the first one is option A, is a payment of $40 a year for 20 years starting in 1 year's time. Now payment starting in 1 year's time is a regular annuity. The payment amount is $40. The time is 20 years, okay, and we have an interest rate of 6%. Everything is annual, so there's no need to convert it to a monthly thing. Everything is straightforward here. You just go ahead and put everything into your calculator. You should get a value of $458.8. Okay. In other words, getting these set of payments for 20 years is the same as getting $458 right now. The same thing. Okay. In this universe where the interest rate is 6%. In some other universe where the interest rate is not 6%, that would be a different number. Okay. So that's option A. Option B, it automatically gives you the present value because you're talking about payment today. A payment of $340 today has a present value of $340 today, right? So that's straightforward. Option C is a perpetuity, okay? It's a perpetuity of $30 starting in 1 year's time, okay? And you can apply the perpetuity formula. And perpetuity formula is PMT by I. So that's $30 divided by 0.06, okay? So that's $500. That's the present value of this set of $30 payments forever, okay? And then you have option number 4. Option number 4 is a single payment of $500 at the end of year 3. So you just have to bring this payment back to today. So this is happening at the end of year 3. What would be its value today is the question. So that's the same as putting in FV of minus 500, N of 3, I by Y of 6 and computing PV, okay? If you compute PV, you should get 419.81. So 4 options, just a second, let me just finish this. So 4 options, 458, 342, 500 and 419. So if you're a reasonable rational investor, you would pick option C because that's the highest PV, correct? Yeah, go on.
Why do we put future value equals 0 for A?
So that's just something that, let me try to explain that one second. So the future value is a number that you put in when let me try to explain. So if you withdraw all of this money at the end of year 20, okay, that would no, let me just reiterate. So what is future value? Future value is a number that's sort of left over, okay? If there's some additions to this or if there's something remaining, if there's something that's unaccounted for, okay? Now, if I calculate it in this manner, if I calculate it in exactly this manner, if I put future value equal to 0, then what I'm saying is this present value accounts for all the 20 payments, okay? If I put any other number as a future value, if I put $10 as the future value, then this number, present value, doesn't account for all the 20 payments. There's a $10 left over at the end of 20 years, okay? So that's why you put future value of 0 in this case. Not clear? So let me explain. So when you put this number here of FV of something, okay, it's the, you're referring to an amount that you received over and above the $40.
I get it, because you're not receiving anything at the end. You're
Yes.
going overtime, therefore. It's
Yes.
zero.
So there's absolutely no other payment except the $40. Okay. So if there was some other payment apart from the $40 at the end of year 20, then that would go into the future value calculation. Okay. So for example, you will encounter this in bonds. When you're dealing with bonds, there's a coupon payment that goes on, and at the end of the coupon payments, at the very end of towards the maturity of this bond, there's a payment of $1,000 that's made out, okay, which is the par value of the bond, okay. And so at that point, you can put in the FE of $1,000 because that's something that you're getting over and above the payments of the coupons, okay. So in this case, no such thing is happening, so I just go ahead with 0. Okay, so option C is better. So, yeah. Question number 7. If the EAR is known to be 16.08% on a debt that has quarterly payments, what is the APR? Okay. So EAR stands for effective annual rate, or some people also call it equivalent annual rate. Nevertheless, it's the effective rate that that's sort of applicable when you're dealing with payments, when you're dealing with compounding periods which are not annual. Okay. If the compounding period is annual, then the APR is the same as the EAR. But if the compounding periods are not annual, then the EAR and the APR are two different numbers. Let me just give you a small example. Let's say that the compounding happens on a semi-annual basis. Okay. And let's say that the APR that they give you is 10%. Okay. So if they give you an APR of 10%, and if the compounding happens on a semi-annual basis, let's say you put $100 in your bank account. Now, at the end of the first 6 months, there's going to be one compounding that's going to happen. Okay, they're going to add some interest to your account. How much interest are they going to add? Well, the APR is 10%, but the compounding is semi-annual. So the rate per month, or the monthly, or the rate per semi-annual rate, it's called, the semi-annual rate, or the rate per 6 months is simply 10 divided by 2, because there are 2 periods in 1 year. Okay, so you're going to get a 5% interest on the amount that you have in your bank account. In other words, at the end of the, so if you have this on January 1st, on June 30th, at the end of June 30th, your account is going to read $100 plus 5% of $100. Okay, and that's $105. Okay, that's what your account is going to read at the end of 6 months. Okay. Now, if you go on to the end of the year, that's December 31st. Okay, that's another 6 months. On December 31st, you're going to get another 5%, but this 5% is going to be on this amount here. That's already there in your bank account. Okay, so you're going to get 105 plus 5% of 105. Okay, so this is 5.25. So this is about 110.25. Okay, that's what your account would read at the end of 1 year. Okay, if the bank follows this kind of a compounding policy. But look at what's happened. At the end of 1 year, you've actually realized more than 10% on your money. You've realized slightly more than 10%, 10.25% in fact, right? You put in 100, you get 10.25. So the effective annual rate for this particular compounding setup was 10.25%. Okay. Now what they're asking us to do in this question is, we know that there's a company, we have to do the reverse. We have the EAR, we need to go back to the APR in this question. Okay. So let's see how to do that. So there's several ways. The first is you can just use a formula. There's a formula which can directly do this for us. 1 plus EAR is equal to 1 plus APR divided by M raised to M, where M stands for the number of compounding periods in a year. In this case, M would be equal to 4. Okay, so you can sort of solve this equation. It's a pretty, it tends to become a bit messy, because to solve this, If this is 4, then you need to take the 4th root of this number and so on. It becomes messy. So that's one way to do it. You'll definitely get the answer through that.
Is it M? Excuse me.
I'm sorry? M. Yeah.
Stand for monthly payment?
M stands for the number of compounding periods in 1 year. Okay. So if it's quarterly compounding, then M is equal to 4. If it's semi-annual compounding, then M is equal to 2. If it's monthly compounding, then M is equal to 12. Right? That's the number of periods in 1 year. Okay, number of compounding periods in 1 year. So we can just go ahead and use the formula, and if you just apply the formula, you'll get 15.19%. But let's try to do it in some other way. Let's try to find out how we could do it on a calculators in a much easier way. Okay. So what's happening in this question? There's a investment that gives you an EAR of 16.08%, which means that if I put in $100 at the end of 1 year, I'm going to have how much? Right? That's what it means. That's what EAR means. If I put in $100, then at the end of 1 year, I should have this amount with me in my bank account. Correct? That's what EAR means. So what I can do is I can use my time value of money calculations and calculate the I by Y, okay, in this case. So I have a PV of 100 or minus 100 in this case. I have an FV of 116.08. Okay. I have number of compounding periods. Number of compounding periods in 1 year have been 4. So N is equal to 4. Okay. I key in these things and I compute I by Y. So when I do that, this gives me an I by Y of 3.798%. But remember, this is the quarterly rate. When you calculate things in this manner, this number that you get is the quarterly rate. You just have to get the APR, you just have to multiply this with the number of compounding periods, which is 4. So that's 3.798 into 4, which is 15.19%. Okay. So there's two different ways you can approach this. One is a straightforward calculation. If you know the formula, you can just solve it on your calculator. The other is to assume that you invested $100 and then that led to a future value of 116.08, and then you compute the I by Y. Okay. Yeah. Any questions on this? Yeah.
Why is it in that formula it's -1, and when you wrote it, you just put -1? I mean, it's supposed to be there or just?
Here?
Yeah.
No, this is just, so this is the formula that I used.
Yeah.
And when you do that, you have a +1 here, right?
Okay.
So I subtracted 1 on both sides. Okay, or rather I took the 4th root. There's a +1 here rather. Okay, so here you take the 4th root and then you bring this 1 here. You subtract 1 on both sides, and yeah, this is just algebraically correct. I mean, this and this are the same formula. You can sort of it's the same thing. I've not done anything extra here. Okay. Okay, so moving on, let's go to question number 8. So as we saw, option C was correct, 15.19%. Okay, let's go to the next question. So I'll give you a minute to read the question. Okay, so Miller's Hardware plans on saving $42,000, $54,000, and $58,000 at the end of each year for the next 3 years respectively. Okay, the word respectively is very, very important. It means they're happening in this order only. Okay, at the end of the first year, 42,000. At the end of the second year, 54,000. At the end of the third year, 58,000. Okay. Now, how much will the firm have saved at the end of 3 years if the rate is 4.5%? Okay, so it's pretty straightforward. Again, there's one payment happening here, one payment happening here, one payment happening here, and all we want to find out is what is the value of these payments at this point in time. Okay, at time 3. Okay, so this has to be pushed to this point in time. This has to be pushed to this point in time. And the payment that's happening at this point in time, you don't have to alter it. It's going to be the same at that point in time. Okay, that's one way to do it. So the straightforward way would be to try and find the future value of 42,000 for 2 years, find the future value of 54,000 for 1 year, add these two and add the 58,000. That would give you an answer. That's one way to go about things. But let's see if we can do it in some other way. Let's see if we can sort of use our calculator to try and speed up things a little bit. So now on your calculator, we are going to deal with a separate bunch of buttons. The buttons that we'll be dealing with are called the CF buttons. the cash flow buttons. In the cash flow buttons, there are 3 buttons: CF, NPV, and IRR. Okay, those are called the cash flow buttons, and we'll be dealing with those right now. Okay, so the first method I told you was simply finding the future value and then adding them all up. That's what's described here. Let me get to the second option B. Okay, so in option B, we try to use the CF buttons. So you have to be very careful while using the CF buttons. The CF buttons have the same problems that the TVM buttons have if you don't clear the memory. Okay, so the very first thing that you do when you're going to use the CF buttons is to clear the memory. Okay, now again there are various calculators which have different sort of mechanisms to them. I'm just going to try and follow the mechanism that I know. So I click on the CF button. Okay, and just to be sure that everything is clean, I click on the down arrow button because I want to know what the numbers are. Because usually you'll find that the first cash flow tends to be 0, and the second cash flow onwards people start putting in numbers. So I click the down button just to see what the status is right now in the CF buttons. Then I click on second, okay, and I click on clear work. Okay, this button here, the CE/C button, but the function that actually gets operated upon is the thing that's written on the top. That's CLR work. CLR work clears all the remnant stuff in the cash flow buttons setup. Okay, so you have to do that. It's very, very important. If you don't do that, you're going to end up with wrong answers. Okay, so let's put in the CF buttons now. So CF, it's going to ask you for CF0. CF0, what is CF0? CF0 is cash flow that happens at time. At time 0, at time right now. Is there any payment that's happening right now? There's no payment happening right now. So I just click on 0 and enter and then down arrow again. Okay, C01 is the first payment that's happening. Okay, the first payment is happening at time 1, and that's a payment of 42,000. So 42,000 and enter and then down arrow. Okay, and then you encounter something interesting. It's called F01. What does F stand for here? Frequency. The F here stands for frequency. How many times is this payment of 42,000 happening? Okay, in our example, in this particular question, it's just happening once. So the frequency is just 1 and enter. Okay.
Usually you don't need to enter the 1 though. Doesn't it just
I'm just doing it for completeness. Yes, you don't have to. If it's already 1, you can just go to the next one. Yeah. Okay. Yeah. Okay. So then, yeah, C02. It's the second payment. That's 54,000. And then enter, and then down arrow 1 and enter, and then you have 58,000 and enter, and down arrow and 1 and enter. So at this point in time, all the information that we know about the cash flows has been fed into the calculator. Okay, the calculator is able to construct the timeline, if you will, internally. Okay, so now we just have to click on the NPV button here. There's an NPV button. You click on that. It's going to ask you for an I. Okay, now the I in this question is 4.5%. So here you just click 4.5, not 4.5%. Okay, just 4.5. Okay, and enter, and then down arrow. And now you can calculate either the NPV, which is the present value of all of these payments at time 0, but we don't want that. We want something else. What do we want? We want something called the NFV. Okay, NFV stands for the net future value, and that's the value of all of these payments at the last point in time according to the calculator's timeline. Okay, so it's going to look at when was the last payment made according to the timeline that you fed into it, and it's going to calculate the future value for that point in time. Now in our calculator, we just put in exactly 3 years, so it's going to calculate the future value. It's going to calculate the value of these payments at the end of year 3. So I'm just going to click on, so I just come down to NFV and then I click on compute. Okay, and that gives me 160,295, and there's an option B that matches this.
exact same thing, and I got 160,000.
Okay, so maybe are you using 4 decimals?
I used 5, but still.
Okay, we can have a look at your calculator after the class. Okay, I'm sorry? So once you click the NPV button, you see an I, right? I equal to something. So you feed in the I at that stage, and then you press the down arrow button twice. If you press it the first time, you see NPV. If you press it the second time, you see NFV. Okay, it might have something to do with the type of calculators that you have. How many of you have this calculator here? Okay. We'll have a look at it later on. I'm not too sure. Or let me just have a look at it. Okay. Well, okay, we can sort of work with that as well. Okay, I can see why you guys are having an issue. So, yeah, on my calculator, I can actually see the NFV, but okay, you guys can't see it. So let's try to solve it using the NPV then. Okay. So let's calculate the NPV. Okay. So what's the NPV? The NPV is this number here. Okay. 140,466.00 or 01 rather. Okay. So most of you are not getting the NFV function or NFV functionality on your calculator. So there's another way to work around this. Okay. The way to work around this is you compute the NPV. Okay. Now what does the NPV tell you? The NPV tells you that this is the value of all of these cash flows at time 0. Now to calculate the value of all of these cash flows at time 3, I just need to push this 3 years ahead. Okay. And that's just compounding. Okay. So to just push this by 3 years ahead, I put this as the PV. I put n equal to 3. I put I by y equal to 4.5, and I compute the FV. Okay. So for those of you who are not getting the NFV functionality, you can try doing this. Okay. You calculate the NPV. You can try putting a minus sign here if you want to get a positive number. Calculate the NPV. That's the present value of all of these cash flows. The question is asking you for the future value of all of these cash flows. So you go back to your time value of money functions, put this as the PV, put n equal to 3, put I by y equal to 4.5, and compute the FV. And that should give you the same number here. Okay. So there's various ways to do this if you're not getting the certain functionality that you're looking for. Is this clear? This alternative method. Did you all get this? 160292? Okay, so yeah, 295 rather. And we'll discuss the issue with your calculator after the class. I'm not too sure what's wrong with the calculator, but if you have 4 decimals, then you should not face problems basically. But anyway, okay. Is that clear? How do we go about doing this? Okay. Let's go on to the next question now. So, yeah. How much more is a perpetuity of $1,000 worth than an annuity of the same amount for 20 years, assuming the interest rate is 10% and cash flows happen at the end of the year? And pretty straightforward. So you find the present value for perpetuity. The present value of perpetuity is simply PMT by I. That's $10,000. The present value of the annuity, you can again feed the data points on your calculator. There's a PMT of 1,000. Put in the negative sign if you want the positive answer. There's an n of 20. There's an I by y of 10. And there's a FV of 0, so you get a PV of the annuity as $8,500. And so the difference between these two is what we're looking for, and the difference between these two is about 1,486.44. Okay, extremely straightforward. You just need to be able to calculate these two numbers correctly, basically. So the answer is option B, 1486.44. Any questions? Okay, let's move on. So the sum of 3,000 is deposited into an account paying 10% annually. If 1,206 is withdrawn at the end of years 1 and years 2, how much is left in the account at the end of year 2? Okay. So this is again a slightly interesting question. So there's $3,000 that was put into an account. Okay. And at the end of year 1 and year 2, some money was withdrawn from the account. Okay, and we just need to find out what's left in this account at the end of year 2. Okay, that's what this question is asking us. So again, there are several ways to do this. You can sort of push 3,000 2 years ahead. You can push 1,000. There's lots of not 2 years ahead. You push the 3,000 1 year ahead. Okay, you find how much the 3,000 has become at the end of 1 year. Then you subtract the 1,206 because that's a withdrawal. Okay, and then whatever is left over, you push it for 1 more year, and then you subtract 1,206 again. Okay, That's a pretty straightforward way of doing things. Let's see if we can do it using a cash flow buttons. Okay. So to solve this using a cash flow buttons, we can sort of try and see what's happening from the bank accounts point of view. From the bank accounts point of view, there were 3 cash flows. Okay. There's a cash flow at time 0 of 3000. Okay, and there's a cash flow at times 1 and 2. So C01 was 1206 with a negative sign. Remember, these two must have opposite signs. One is a deposit, the other is a withdrawal. Okay, you can choose to make this positive, but if you choose that, you must make this negative. Okay, because they're in 2 different directions. They cannot have the same signs. So I've just arbitrarily chosen this to be positive, and you made the withdrawals as negative. Okay, so 3000 is one cash flow, then 1200 was withdrawn for 2 years. So F01 here becomes 2 because the withdrawal has happened twice. There's a frequency of 2. So you feed in these numbers, and once again you calculate the NFV. Now again, most of you don't have the NFV, so you compute the NPV and then push it 2 years ahead. Okay, that's one thing you can do. If you do all that, you should get 1097.4. Is that clear? Okay, so the answer to that question is option C, 1097.4. Okay, so let's do this one. So the present value of an annuity stream of $100 per year is 614 when valued at 10%. But approximately how much would this value change if these were annuities due? So annuities due are those annuities where the payment begins from the beginning of the first period, not at the end of the first period. Okay, it's called a regular annuity if the payments are at the end of the year, but it's called an annuity due if the payments are at the beginning of the year or at the beginning of the period. Okay, now there's a very, very simple, straightforward formula which links the annuity due and the annuity and the regular annuity, and that formula is that the present value of an annuity due is simply equal to the present value of a regular annuity multiplied by 1 plus I, where I stands for the interest rate in percentage. Okay, so the present value of an annuity due in this question would be equal to the present value of the regular annuity, which is $614, multiplied by 1 plus I here in this question is 10%. So 10% is 0.1. So 1 plus 0.1 is 1.1. So the present value of the annuity due would be $675.4. Okay, and so the difference between the present value of an annuity due and the regular annuity is simply 675.4 minus 614, which is $61.40. Okay, pretty straightforward as long as you know this relationship here. Okay, so this relationship is true because all the payments have had one extra period to compound. Okay, because the payment is happening at the beginning of the year, they have the first year to compound basically. Okay, so that's why they have one extra year compared to a regular annuity, and therefore the present value goes up by that factor. That factor is one extra year of compounding. Okay, let's move to the next question. Option B was the answer here. Question number 12. Lottery prizes are often not worth as much as claimed. What is the present value of a prize of $5 million that is to be received in 20 equal yearly installments with the first payment beginning today? Assume an interest rate of 7%. Okay, so if you're lucky enough to win a lottery, you'll find out that when they say it's a 5 million lottery, what they are going to do is they're going to make payments of 5 million divided by 20. Okay, they're going to make the payments of this number, which is simply, let's calculate that. So that's 250,000, so 250,000 per year. Okay, so when you win a $5 million lottery, in this example, what's actually going to happen is you're going to get a payment of $250,000 every year. Okay, it's not that the value of these payments is worth 5 million right now. It's just that these payments are going to be divided over 20 years in time. Okay, but that's the key thing. The present value of these payments today is going to be different from 5 million. It's going to be a slightly lesser number. Okay, and we'll see what that number is in just a while. So the payments that you're actually going to get are $250,000 every year for the next 20 years. Okay, and the interest rate is 7%. okay, and we can go ahead and compute the PV, but there's a small hiccup here. What's the small issue here? The issue here is that the payments are happening at the beginning of the period, okay, and when the payments happen at the beginning of the period, you have to make a small adjustment to your calculator, okay, to make sure that it's taking into account the beginning of the period, and the small adjustment is what is called changing the mode of your calculator from end mode to begin mode. By default, your calculators are on what is called the end mode, okay. In other words, when you use the TVM functions, the calculator is naturally assuming that the payments are happening at the end of the year, okay. But you can change that. There's a way to change that setting on your calculator. So to do that, let's try to change the setting on your calculator. You click on the second button first, second, and then you can see the PMT button. But on top of the PMT button, you can see a small BGN written, right? The BGN stands for begin. So you click on PMT, and then you click on second again, and you click on enter. Okay. If you do that, now you can see a small BGN written on top of your calculator, the top line. And what this means is your calculator now understands that all the payments that you're going to do, all the payments that you're going to enter are happening at the beginning of the period rather than at the end of the period. So you don't have to do anything more. You've told the calculator already that that's what's going to happen. I'm sorry? So you click on second, you click on PMT, then you click on second again, and you click on enter. Okay. So that sets the calculator in the beginning mode, okay, or the begin mode. And now you just feed in these data points that we have here: PMT of 250,000, N of 20, I by Y of 7%, okay, and compute the PV. Okay. When you compute the PV in this manner, you're going to be computing the present value, assuming that the payments are happening at the beginning of the period. Okay. How do you get out of it? How do you get into it?
I'm trying to compute PV right now after entering that data, and the BGN is still there. And
Yeah.
I can't.
So did you get the answer?
I wasn't able to because the BGN is still there. Meaning I'm pressing it, and it's like, it's not coming out.
You can just restart the calculator if you want. You'll still have the BGN written on top, right? Okay, so now you just put in the numbers. So you put in $250,000 as the PMT with a minus sign just to get a positive number, N equal to 20, and I by Y equal to the 7%. And you can compute the PV. And if you do that, you should get this number here, 2833,898.81. Okay, so this is the just a second. So this is the present value when we have explicitly told the calculator that the payment is happening at the beginning of the period. So this is the answer that we want. Yeah.
So, as I see, like we have 45 minutes left.
So, I know. Let me move on.
Are we going to do the other parts?
We will try to do as much as we can.
If not, so that's it.
Let's try to. Let me see if I can arrange some snacks later on. Let's see. So anyway, let me see. I'll try to hurry up as quickly as possible. But anyway, so did you guys get this? 2833,898.81. Okay. So now, before we go to the next question, you need to try and get back to your end mode again. Okay. So to get back to your end mode, click on second. Okay. Click on PMT. Click on second and click on enter. Okay. And that will bring your calculator back to your end mode, the default mode that we operate in. Okay. So that's something that you can do. Okay, let's move on. So you have just retired with savings of $1.5 million. If you expect to live for 30 years and earn 8% on your savings, how much can you afford to spend each year? Assume that the spending occurs at the beginning of the year. Okay, again a very straightforward question for the beginning mode thing. So you have retired with $1.5 million. So that means there's a bank account somewhere with $1.5 million in it right now. Okay, and you're going to you're assuming to live for the next 30 years. Okay, and so you're going to get 8% on that bank account, and we need to calculate the PMT that you can keep withdrawing from the bank account. So to do that, first we go into the begin mode, and then we put in the numbers that we know. We have a PV of $1.5 million. I put in a negative sign because I want a positive answer. I have I by Y of 8. I have N of 30, which is number of years. FV of 0 because at the end of 30 years I'm assuming that I'm going to die, so I don't want any more in my bank account, and I compute the PMT. Okay, and so if I do that, I get this number here, which is 123,371.44. Okay, so that's option B, and that's the answer to this question. Okay. Okay, what is the present value of the following payment stream? Discounted at 8% annually, $1,000 at the end of year 1, $2,000 at the end of year 2, and $3,000 at the end of year 3. Again, a very straightforward CF question, cash flow question. So CF0 is 0, C01 is 1,000, C02 is 2,000, C03 is 3,000. All the F's are equal to 1. You calculate the NPV and compute the NPV. Very straightforward. You should get 5,022.1. Okay. Moving on, question number 15.
Would you be able to send out the solutions to these?
We will be sharing these with the instructors, and
Yeah, but some of us have our exams tomorrow.
okay, we'll try our best to see what we can do.
All right,
about it.
thank
I
you.
don't know. Let's see. So let's go to the next question. So the next question is, John and Peggy recently bought a house. They financed the house with $125,000. It was a 30-year mortgage with a nominal interest rate of 7%. The mortgage payments are made at the end of each month, so it's a monthly payment. What total dollar amount of the mortgage payment during the first 3 years will go towards the repayment of the principal? Okay. Now here we are going to use what you talked about at the first question. Okay. So we need to try and find out. So they've been making payments for the first 3 years. That's 36 months. How much of these payments have gone towards the principal? Okay. How much has the principal gone down? That principal at the beginning of this entire mortgage was $125,000. By how much has it gone down is our question. So to solve this question, the first thing that we need to do is to try and find out how much are they paying every month. What is their monthly payment? Okay, so that's what I do in my first step here. Okay, so I have a PV of 125,000. I have N of 30 into 12, which is 360, because it's a monthly thing, so it's 360 months. I have I by Y, which is 7 by 12. This is a monthly rate. 7% is the annual rate, so I do 7 by 12. And then I compute the PMT of 831.63. So this is the amount that John and Peggy will pay every month, $830. Okay. Now, after John and Peggy make the first 36 payments, that is the first 3 years, we can compute the amount that is still owed by John and Peggy to this bank. Okay. So how many payments do they have left over? They have 324 payments left over. Okay. And we can calculate the present value of these 324 payments. Okay. So the present value of the 324 payments, to do that you just have to feed in these numbers here. So you have a PMT of 831.63, that's the payment that's happening every month. You have an I by Y of 7 by 12. You have N of 324, this is the key difference here. You're trying to find out what is the principal that's still left over after the first 3 years, okay, when you still have 324 payments to go. So that's N equal to 324, and you compute the PV and you get 120,909, okay, $120,000, roughly 121,000. Okay, so that means at the beginning of the 30-year period, John and Peggy owed this bank or this mortgage company 125,000. After 3 years of making payments, after making 36 payments, they still owe this company 120,000. Okay, so their principal has gone down by the difference between these two numbers, 125,000 and 120,000, which is just about $4,000, $4,090. Okay, so try to see what's happening here. Their mortgage was for 30 years, and they have been paying for 10% of the life of this loan. Okay, but the amount that they have actually paid back is about 3% or 3.5%. Okay, and that's the key thing to note in these kinds of questions. Okay, any doubts about this question here? So this is pretty straightforward, provided you know what I did. So first I calculated the PMT, and then based on the PMT I calculated how much money is still owed by John and Peggy for the remaining 324 payments. Okay, and then I just computed the difference of these two numbers. So the answer for this question is $4,090.98. Moving on. If you're valuing an investment that will pay you $26,000 per year for the first 9 years, $34,000 per year for the next 11 years, and $47,000 per year the following 14 years. All payments are happening at the end of the year. Another similar risk investment alternative is an account with a quoted annual interest rate of 9% with monthly compounding of interest. Okay, so there's two layers to this question. The first layer talks about all the cash flows. Okay, in the second part of this question, the second statement of this question is talking about a similar investment alternative. Okay, and that similar investment alternative has an APR of 9%, but the compounding is on a monthly basis. Okay, so this is something that you're going to see in finance. When two things have the same risk, they must have the same EAR. They must have the same returns. Okay, if they don't have the same returns, then there's something called arbitrage that can happen. Okay, so essentially we need to try and find out what is the EAR that's applicable to the first one. Okay, by computing the EAR from the second statement. So we compute the EAR from the second statement, the effective annual rate from the second statement. So the effective annual rate from the second statement, you can just do it using the formula, or alternately you can assume that you're putting in $100 in a bank that's going to be compounded for 12 months at a monthly rate of 9 by 12, because that's the APR that's quoted, and you get an FV of 109.3807, which means that the EAR was 9.3807%. Okay, so the EAR for the second investment, the alternate investment, was 9.3807%, and because the first and the second have the same risk, the effective rate for the first set of cash flows is also 9.3807%. In other words, the I by Y that you're going to apply to the first set of cash flows is 9.3807%. So you just go ahead, you put in all the cash flows, CF0, C01, F019, C02, F02, C03, F03. Then you click on the NPV button and you feed in the I. The I that you're going to feed in is going to be 9.3807, because that's the applicable rate for these set of cash flows. And then you compute the NPV. You should get 314,518.20. Okay.
Where's the 0.308 coming from the 9%?
So that's because, so the 9% was a monthly rate. I'm sorry. The 9% was an APR, but that's happening at a compounding period of 1 month. Okay, this compounding frequency is monthly. So you have to try and find out what is the effective rate for the year. And the effective rate for the year is 9.38%. Okay, 9.3807.
The EARs.
Yeah.
Okay.
Okay. And because for the first cash flow, the cash flows are happening at the end of the year, the applicable rate would be some kind of an annual rate. Okay. If you look at the first statement, all the cash flows in the first statement are happening on an annual basis. So you have to use the annual rate basically. And the annual rate is the effective annual rate, which is 9.3807%. Okay. Okay, so in this question, if you use 9.38, you might get a slightly different answer, so just be careful. I tend to use 4 decimals just to be safe. Anyway.
When exactly do you know when to use the EAR rather than the APR?
So two investments can only be matched when they have the same kind of frequency. The timings must be the same. Okay. Now one investment is happening on a monthly basis, the other investment is happening on an annual basis. So you bring them both to monthly basis or you bring them both to an annual basis. You need to do one of these two things. Okay. So that's the only place where you can compare them. Otherwise you cannot compare anything basically. Okay. Let's go. Just 2 more questions from me and then we can move on to chapter 6 and 7. So you're planning for retirement 34 years from now. You plan to invest 4,200 per year for first 7 years, 6,900 per year for the next 11 years, and 40,500 per year for the following 16 years. Again, pretty straightforward. You have to find what's called the NFV in this question as well, because they're asking you for the value of the account several years from now, 34 years from now. So CF0, C01, F01, and so on, and you compute the NFV. And for those who don't have the NFV functionality, compute the NPV, compound it by 34 years to get the NFV. Okay. So for those of you who don't have the NFV functionality on your calculator, calculate the NPV. Okay. And then compound it for 34 years. You find the future value of this amount by putting in this as the PV. You put N equal to 34, you put I by Y equal to 9.7, and then you compute the FV. Okay, for those of you who don't have the NFV functionality. So this is 1542 and so on. And last question from me. Sharon Marsh just graduated. She plans to work for 5 years and then leave for the Australian outback country. she figures that she can save $3,500 a year for the first 3 years and $5,000 a year for the next 2 years. These savings will start 1 year from now. In addition, her family just gave her a graduation gift of $2,500. If she puts this gift and all the future savings when they start into an account that pays 7.75%, what is the financial stake when she leaves for Australia 5 years from now? So basically, she's going to put the $2,500 that she gets into a bank account, and then for the next 5 years, she's going to keep getting some income, $3,500 for some years, then $5,000 for some years, and so on. Okay, she's going to put all of this money into one bank account, and that bank account pays 7.75%. And all we're asking is, at the end of 5 years, what is the amount that's there in this bank account? Okay, so again, this is again an NFV kind of a question. So you can use it using your cash flow button. So CF0 is 2,500. Here you do have a CF0 because there is something that she puts into the bank account right now, and that's the graduation gift that she received of 2,500. The C01 of 3,500, and she gets that for 3 years. So F01 is 3 years. The C02, which is 5,000, she gets that for 2 years. So F02 is 2. Okay, and then you have you click on the NPV button. You key in I equal to 7.75. And for those of you who have the NFV functionality, you go down to the NFV and compute NFV. For those of you who have the NPV functionality, compute the NPV and compound it by 5 years at 7.75%. If you do all that, you should get 27178.24. And that will be the amount that's going to be there in her bank account 5 years from now when she goes to Australia. Any questions about these kinds of cash flow questions and how to solve them? There's no other payment, there's only one payment, there's only the first, yeah, the PMT is 0, the PV is the amount that you calculate, okay, and then you go ahead. Okay, so that's all from me for now. We're going to move on to chapter 6 and 7, and Mr. Yushan is going to take over.